Is the secret to your inner world a magnificently complex algorithm running on the wetware of your brain? Or is it a symphony of collapsing quantum states, a gravitational echo that ripples through the architecture of your neurons with every conscious thought? Right now, as you read these words, you're actually performing an act of incredible complexity. Information flows from this screen through your eyes and into the intricate network of your brain. Your mind processes the shapes of these letters, converts them into sounds, and assembles them into concepts. This is the chasm that separates mere information processing from the subjective reality of consciousness, the internal movie that you are living right now. The idea is that if you build a system with enough interconnected nodes and processing power, consciousness will simply switch on like a light bulb finally receiving enough current. The dominant scientific theories of consciousness, such as the Global Neuronal Workspace, or GNW theory, focus on the computational architecture of the brain. GNW proposes that you become conscious of a piece of information when it is broadcast across a widespread network of neurons, making it available for various cognitive processes like memory, planning, and language. Another leading computational model, integrated information theory, or IIT, takes a slightly different but related approach. A system with high phi, like the human brain, has a structure where the whole is vastly more than the sum of its parts. Both GNW and IIT are hardware agnostics. They imply that if we can replicate the brain's functional architecture, its global workspace, or its integrated information structure, in a silicon-based machine, we will have created genuine consciousness. The machine would not just be an inner life, it would actually have one. The radical alternative, championed most famously by the mathematical physicist Sir Roger Penrose, argues that the computational story is missing the most important chapter. Penrose contends that human understanding, particularly our ability to grasp mathematical truths, possesses a quality that cannot be captured by any algorithm. This something else Penrose proposes is the physics of reality at its most fundamental level. Penrose suggests that it is not an external observer but gravity itself that resolves this ambiguity. This process, called objective reduction, or OR, is a proposed physical law, not just an interpretation. The theory, developed with anesthesiologist Stuart Hameroff, is called orchestrated objective reduction, or ORCH-OR. It hypothesizes that this gravity-induced collapse is not random noise but is orchestrated within the brain, specifically inside tiny protein structures within our neurons called microtubules. Each moment of orchestrated collapse, according to ORCH-OR, corresponds to a moment of conscious experience. This leads to a beautiful and simple equation. Tau equals h bar divided by EG. Here, tau is the time it takes for the superposition to collapse on its own. H bar is the reduced Planck constant, a fundamental number in quantum mechanics. And EG is the gravitational self-energy of the superposition, a measure of how much the two separated versions of the mass particle are pulling space-time apart. The equation shows that the lifetime of a superposition is inversely proportional to its gravitational energy. If we could find a way to subtly change the mass of the components involved in the supposed quantum state without changing anything else about the system's chemistry or computational structure, we could see if it affects the timing of conscious processes. But if ORCH-OR is correct and consciousness is tied to gravitational collapse, then increasing the mass should increase the gravitational self-energy, EG, which in turn should shorten the collapse time, tau, leading to a measurable change in the frequency of conscious moments. It would provide the first ever experimental evidence that a quantum gravitational process is happening within the brain and is directly linked to the timing of conscious experience. It is a testament to the power of science that a question so vast, so central to our identity, could hinge on a detail so small.